Good morning, everyone. We are going to be going through the basics of Unit 3 in the next couple of videos. And in this one, I want to focus on valence electrons and charge. This is something we actually did in Unit 2, but it's coming back up again in Unit 3. And so I want to review and make sure that we're all on the same page. So first of all, what is a valence electron? Okay, so remember, a valence electron is shortened or symbolized by a V, an E, and then the negative symbol as an exponent. And that's because the E with the negative sign is the symbol for electron, so you just put a V in front for valence electron. And these are the electrons in the outer energy level, or the highest energy level. So in our image here, we can see that we have 6 positive protons that are red in the nucleus, and we have neutrons that are blue. And so because there are 6 protons, this tells me we're talking about carbon. Okay, so this particular atom is an atom of carbon. It has 6 protons, 6 neutrons, so it's got a mass of 12 total. 6 plus 6 is 12. And then we have these 6 electrons. Now notice 4 of these electrons are on the outer energy level, okay? And those electrons would be considered the valence electrons. So this atom of carbon has 6 total valence electrons, 6 total electrons in general, and only 4 of them are valence electrons. Now, when you're looking at your periodic table, you can identify how many valence electrons there are just by looking at its column number. So for example, everything in column number 1 is going to have 1 valence electron. Everything in column 2 will have 2 valence electrons. Now, these columns, they can vary, so we kind of skip them for now, because it changes up depending on what element you're talking about. Remember, when we look at electron configuration, this is the D subblock, and it gets a little tricky there. When you're in column 13, because the 3 is the last number, there are 3 valence electrons, and then column 14 has 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons, and then column 18 has 8 valence electrons. Now, being able to identify how many valence electrons it has very quickly by looking at the periodic table is extremely important. So for example, if I say how many valence electrons does nitrogen have, you should know that nitrogen is right there on the periodic table, so it has 5 valence electrons. Or that calcium is right here on the periodic table, so it has 2 valence electrons. Or that neon has 8 valence electrons because it's in column 18. Now, the only atom that does not follow this rule is helium. Okay, and the reason why is because remember when we talked about how in electron configuration, it looked like there was a box right here missing, okay, and we talked about how it's helium. Helium only has 2 electrons total, and that means both of them are 2 valence electrons, even though it's in column 18, okay, but it has that full energy level. And the reason why that's important is because of a rule that we learned about called the Octet Rule. Okay, now the Octet Rule says that atoms are going to gain or lose valence electrons. Okay, so they're going to gain or lose valence electrons to have a complete valence shell or a valence energy level. Okay, now usually that means 8. Okay, so remember when we look at atoms, so for example, let's look and compare beryllium to oxygen. Oxygen. Okay, beryllium is number 4 on the periodic table, so it has 4 protons. So if I were to draw a Bohr model, I have 4 protons in the center. The mass is 9, so 9 minus 4 means I have 5 neutrons. It is on row number 2 of the periodic table because beryllium is right here, okay? And so that means it's going to have 2 energy levels. So 1, 2. Remember, there are only 2 boxes on our first row on the periodic table, so that means there can only be 2 electrons maximum on that first energy level. And then the other 2 electrons will be right here. Now, because it's in column 2, it has 2 valence electrons as seen by the Bohr model. Oxygen, on the other hand, is in column 16. So we know it's going to have 6 valence electrons. But what does that look like in a Bohr model? Well, oxygen is going to have 8 protons and 8 neutrons because of its atomic number and mass. It's also on row 2, so it has 2 energy levels. That first energy level holds 2 electrons, and because it has 8 total, that's 1, 2, and then 3, 4, 5, 6, 7, 8. And so we see that there are 6 valence electrons on that outer energy level. Okay, so when we have this octet rule, right, you want to have atoms that have a full valence shell. And right now, we know that the second energy level, okay, the second energy level is full when there are 8 valence electrons. Sorry if you can hear the bell ringing in the background of this video. Okay, so the second energy level is full if there are 8 valence electrons. And we know that the first energy level is full when there are 2 valence electrons. So both beryllium and oxygen have their first energy level is completely full. So we have to decide what's going to happen. And the reason why they're gaining or losing these valence electrons is right now they're not stable, okay? They're reactive. They want to be stable and have a full shell. So beryllium has 2 options, okay? Option number 1, okay? Let's say it was gaining electrons, okay? So option number 1 for both of these is going to be gaining electrons. In order to get to 8 electrons, beryllium could gain 6 extra electrons, okay? For oxygen would need to gain 2 valence electrons to get to 8, okay? It has 6 valence electrons, it would need 2. Beryllium could gain 6. Now, the second option is what if instead of gaining, it lost? Because this energy level on the inside is already full, okay? That energy level is complete. And so its second option, beryllium, if it wanted to get rid of its valence electrons to just have that first energy level, beryllium would need to lose 2 electrons, those 2 valence electrons. Oxygen, however, would need to lose all 6 of its valence electrons. Okay, and I probably should have had these as valence electrons, not just regular. Okay, and so what happens is these atoms are going to do whichever one requires the least amount of energy. So basically, which one is the easiest, to gain or lose a smaller amount of electrons? So what beryllium's going to do is it's going to lose 2 valence electrons because that's the smallest amount. But oxygen is going to gain 2 valence electrons. So what happens is this electron and this electron are gone. And when they leave, that means that beryllium will become a cation with a positive 2 charge. Now remember, your charge, we did a calculation for this in Unit 2. Your charge is always equal to your protons minus your electrons. And so if I get rid of 2 electrons, I had 4 protons minus, now I only have 2 electrons, so that's a positive 2 charge. Now for oxygen, oxygen's going to gain 2 electrons, so it's going to add 2 extra electrons that were not there before. And so now its charge, again, protons minus electrons, I have 8 protons, but now there's a total of 10 electrons. And so that would give us a -2 charge. So that means oxygen forms an anion, or an atom with a negative charge. Now, the great thing about this is you need to understand why this is happening, but your periodic table means that you don't have to go through this process every single time, okay? When we look at our periodic table, we know that column 1 always has 1 valence electron, which means that they're always going to lose that 1 valence electron. So imagine if you were to have like a number line from 0 to 8. If you only have 1 valence electron, you're much closer to 0 than you are 8. So you're always going to lose electrons. So that means anything in column 1 is going to form, and let me decrease the size of this pen, a +1 charge. Anything in column 2, like beryllium, we said is going to lose those 2 valence electrons and form a +2 charge. Again, these can have multiple charges because their valence electrons changes. So this is something that I would tell you what charge that atom has, or I would give you a way to figure it out, and we'll learn more about that in Unit 4. If I have 3 valence electrons, I'm still closer to 0. So we're going to lose those 3 valence electrons and have a +3 charge. Now, if I have exactly 4 valence electrons, that means I could gain 4 to go to 8, or lose 4 to go to 0. It's exactly in the middle. So what happens is you can, depending on what element it is, you can have a +4 charge, or you can have a -4 charge. It kind of depends. But if it's a metal, it will always be positive. Okay, it'll always be a cation. Now, if I'm on column 15, I have 5 valence electrons. And so here's the thing that you got to remember about the charge is if I have 5, I'm closer to 8, and I need 3 more to go to 8. So that means I'm going to have a -3 charge. If I'm in column 16, I have a -2 charge, like oxygen, which we did before. Column 17 would be -1. And column 18 already has 8 valence electrons. So it will have no charge. It will be neutral because it already has 8. It's not going to gain or lose valence electrons. And so this is a very critical part of our unit that we base a lot of information on, is knowing these charges and knowing how many valence electrons something has. Okay, so understanding that we're going to gain or lose valence electrons. Okay, so hopefully you found this video informative and helpful. Check out the next one.